Hi class 10. So this is the last part of water resources, and with this all the chapters before your pre-boards would be completed. So this is water resources part 2. In first part we learned about rainwater harvesting, we learned about other methods of conservation, we learned about the need for conservation and etc. And this portion is mainly about what you see on the picture. So the more you save water, the more we'll be able to grow plants, because plants are life, and the more we save water, the more we save life. So it's all about growing crops and growing plants, and how much of saving water is essential to do that, because all of us depend on crops and plants for life, for livelihood. So this term irrigation is a common term you would have heard many times, but conservation of water and giving water to plants is very, very interrelated. And the relationship between how much we need to conserve water and we need to use it to grow plants is what we'll be discussing in this video lesson. So as you know, the top part of water resource is completed. Just the bottom part, irrigation, its importance, the need of irrigation, and the methods of irrigation we'll be discussing today. Okay, the term irrigation actually is a process by which agricultural crops are watered throughout the year using various methods. So it's just watering plants or watering crops that's gonna feed us in the coming years or in the future. And we can do it not just with one or two, but various different methods. And to put it all together, we call it irrigation. And uh, this is a common sight which most of us would have seen: water coming out of a pipe and it's just flowing. So, but most of the time when we do irrigation, there's a lot of wastage of water. We can 100% tell that the water which is coming out through this pipe is not 100% going to be used for plants. There's a lot of wastage, there's a lot of evaporation, there would be cracks or breakages in the pipe, and all along the way there will be leaks which will yield loss of water. So we know clearly that there's a lot of wastage of water taking place due to irrigation. So how can we irrigate the crops at the same time save water? The need for irrigation has always been high, especially when we compare to a country like ours. India is a big country, and we know where it stands in the population list. It's just next to China, and we need more facilities and more kinds of irrigation or smart thinking to reduce water loss at the same time to feed the crops, which will in turn feed us. The distribution of rainfall is uneven. Some years it's so dry, no rainfall. Some years there's huge rainfall and there's drought. In some years there's floods in the other year. So it's always erratic and uneven in our country. So irrigation can check all those problems by constantly giving water throughout the year. What about the next point? The different water requirements for crops. Most of the people in the north depend on depend on wheat, while the people in the south depend on rice. Some parts of India depend on maize. So even in a country like us, there's different needs. Not always the same kind of crop is used. Different crops are in more demand in one place. Different crops are in less demand in another place. So we need to use different irrigation techniques to fulfill the needs of the particular place. India being a tropical country, there's so much temperature, so much sunlight, and there's a lot of months in summer when there is evaporation taking place, and the long dry winter season also. So during these seasons, to prevent water scarcity, to prevent drought, we need a constant water supply or an irrigation method adapting to each and every situation. So this is the need of irrigation in our country. Irrigation is not something which started yesterday or today, something which existed for a long, long period of time. As we look into history, we can understand that the Mesopotamian civilization or the Indus Valley civilization or the Egyptian civilization, Chinese civilization, all these civilizations were the beginning of human beings coming together and starting life and starting working together, and they started agriculture along the riverbank. So, and they used the rivers to water the crops. So, irrigation isn't something which started few years ago, it started many thousands of years ago when civilization began. So, there has always been traditional old methods of watering the crops. In our country, there are many traditional methods. So, We're not going to discuss all those, but we'll be discussing four main traditional methods that have been used in our country over a long period of time. And of late, the usage of these traditional methods have come down, but still very rarely we can find these methods still being used. The first one is called moat or bucket system. In this, it's a manual irrigation method where a pulley is also attached to the well, and with the help of the pulley, water is drawn out. And in many homes in the southern part of India, or even in some parts of North India, we can see that wells are there, and this bucket and pulley system is still existing in many parts. So you pull the rope on one side, and with the help of the pulley, the bucket comes up. So there's less manual effort to lift the bucket out, and it helps us to draw the water outside. By this method, water is directly taken out of wells with the help of pulley and is used to irrigate the fields. But this disadvantage is that it's really time consuming, labor intensive process. The person gets tired if it's done for a long period of time, and it is the advantage is that it's cost efficient. There is no usage of electricity or any uh, fuel that's involved in running any motor. So this it's cost efficient, but it's labor intensive. Number two is the Rahat or Persian wheel method, which you would have seen many times in many other parts of our country. It exists even still today. It's a water lifting device which has partly been submerged in vertical wheel, which is a partly submerged vertical wheel with buckets attached to the rim. So it has a huge bucket chain. The chain has many buckets attached to it, and the half of the chain is submerged, or probably one fourth of the chain is submerged in water. So when animals that are attached to this wheel run around or move around the well, it lifts the buckets and it pushes out the water outside. So animals like cow, buffalo, oxen, or any other cattle are connected to the wheel. They move and rotate the wheel. This draws out the water as the chain moves round and round and round, and all the submerged buckets come out with water filled in it and pours it outside. So this is the Rahat or Persian wheel method, which is also a traditional method and still is being used in some places in our. This is also another method which is used using cattle. It's called the moat or the inclined plane method. You must not be confused with the moat method and the Persian wheel method, because inclined plane method, the animals go down a slope and come up a slope. But in the Persian wheel method, the animals go round and round and round a wheel. In the inclined plane method, there's a huge water bucket, or it's a huge bag instance, and it's not a mug or it's not a bucket which is attached to a chain. But on the other hand, in Persian wheel, there's a huge chain and buckets are attached. So in this method, what happens is that it's also a method to irrigate crops using cattle. A pair of bulls draw out water from a well using a huge rubber or leather bag. You can see that in the top part of the diagram, bag in emptying position. It's like a huge sheet or huge cloth bag or a leather bag or a rubber bag. So it carries so much, or it lifts out a large amount of water compared to the Persian wheel method. And as the cattle go down the slope, the bucket goes up, sorry, the leather bag goes up, and it just releases the water down the slope. Due to the large volume of water that is drawn out, an inclined plane helps in reducing wastage. If there is no inclined plane, first of all, it is difficult to lift out that large volume. Second thing is that when the water would be poured out, it will spread in different directions. If it is poured out on an inclined plane, it will directly flow down the inclined plane towards the desired crops. This is the last traditional method that we'll be looking. It's called the Dakely, and it's also called vertical pole method. So here you can see a vertical V-shaped stick which has a gap which will act as the fulcrum of this lever system, and one side we have load and one side we have the bucket. There's another horizontal wooden bar. So this wooden bar on the V, which is placed on the V, will either move forward or backward. The more it moves forward, the bucket will go down. The more it moves backward, the bucket will come up. Always the load will be attached to one end and the bucket will be attached on the other end. The lifting of the bucket can happen only by moving the horizontal stick through the V forward to dip the bucket and backward to lift the bucket. The to and fro movement of the bar helps in lowering the load and the bucket whenever required. The load helps to raise the water when is emptied later by the farmer onto the field. This is the last method, which is the Dakely or the vertical pole method. These are the four major traditional methods, some of the methods are still being used while some have been stopped. Moving into the conventional methods. So we have moved from traditional method to conventional method. Conventional methods are the methods which are used on a large scale. In India, we look most of the places on a large scale. For example, this whole state uses this method, or these states in India use this method. So on a large scale, conventional methods are used. And there are three conventional methods. The first one is canals. Canals are the main source of irrigation in India. Canals are big water channels that take out river water and carry it to places far from the river. So imagine there's a river far and there's an agricultural area far from the river. So these canals are constructed to take out that river water, bring it to the far away agricultural field. There are two types of canals. One is inundation canals. These canals receive water when the river overflows. So for example, when a river is overflowing, it's flooding. When it rises more than its normal height, it will be taken through the canals. There will be canals which is waiting to receive the water when the river is overflowing, and from that it will take it to the nearby streams, and from the streams to the nearby fields. So those kind of canals which is working only when the river floods is called inundation canals. The other one is perennial canals. These canals are taken out from the perennial rivers, which is rivers which always have water, by constructing small dams or barrages or bunds. So if you block the water, as you see in second picture, there's a black color blockage. This increases the water level and it makes sure that the water level flows through the canals, the main canal, then the branch canal, and it just distributes water again and again and again. It can only be done by blocking a perennial river. So perennial canals will always have water. Inundation canals will have water only during flood. So perennial canals are more useful because it has always water and it gives water to the crops all the time. Inundation canals does not do that, but still canals come with disadvantages. The canal irrigation, which is the water table, is only a few feet below the ground. Many salts might come to the surface, it mix with the water because there's a long time when the water is just flowing and at the same time it's touching the soil. So it can make sure that the soil becomes unproductive all because all the time the water is flowing through the soil. Because of waterlogging in canals, the soil absorb a lot of water. The capacity of the soil to absorb water decreases because it's always having waterlog. This can damage the crops and the absence of proper drainage system also. Next is well irrigation. In well irrigation, you can see that uh, you would have seen these structures many times in our country. Wells are the most widespread in northern plains, coast, bringing regions of peninsular India. So when we compare to canals are found in regions where there's a lot of rivers. Along the river Brahmaputra, Godavari, Ganga, Yamuna, you will find all those regions of northern plains in northern India and the northeastern part. And also along the eastern coast, there will be a lot of regions where rivers are present, you will find canals. But well irrigation is mostly common in regions where there's a lot of fine soil, a lot of weathered soil. It is less costly and more flexible as water can be drawn whenever needed, and unlike canals, there is very less evaporation. UP leads in well irrigation, followed by Punjab, Haryana, Bihar, Gujarat, Andhra Pradesh. These are regions where rivers flow, but more than canals, because rivers flow, it produces a lot of alluvial soil, and this soil has a lot of ability to hold water. So it's easy to dig through fine soil, and water holding capacity of that soil is high. So it also makes sure that the water is easily taken out. Wells are of two types, open wells and tube wells. Open wells are shallow and irrigate a small area because the water available is limited. The picture you're seeing on the top is open well, while the bottom one is tube well. Tube wells have deep and the capacity to draw out a large amount of volume. This has increased over the years. It's run using motors, and through a pipe, this tube well releases a large amount of water. It drills out so much amount of water. This is a tube well. Disadvantages of wells: it is difficult to dig wells in hilly regions and northern areas or stony areas in the peninsula. You cannot construct wells there because it's difficult to dig. You can do it only in regions where there's fine soil. Wells can dry up because of lowering of water table. If one region home or one area drills out so much water, the nearby area will have a reduction in water level. Use of electricity or fuel like diesel to operate the wells make it expensive. That's also a big disadvantage of wells. Last one of irrigation is tank irrigation. Tank irrigation is common in uneven and relatively rocky regions. Most of the rocky regions are found in the Deccan Plateau and the Plateau or Peninsular India. These hard unfractured rocks make it difficult to drill but easy to store water with less infiltration. So these rocks are not fractured, so it's difficult to drill a well here. But since it's not fractured, when you store water, it does not seep inside or it can stay above for a long period of time. Tanks are mostly used in the Deccan Plateau regions of Andhra Pradesh, Karnataka, Tamil Nadu, Maharashtra. These regions, 8% of the total irrigated area will be made out of tanks. So this is just a schematic diagram of a tank, how the region is constructed and how it is connected to the underground water and how water logging takes place. Most of the tanks are small in size and built by individuals or group of farmers by raising bunds across seasonal streams. So when seasonal streams are blocked, the water gets collected and it eventually ends up as a tank. Disadvantages: tanks cover a large area of cultivable land. Some tanks are very huge. Imagine the picture on the top. A huge agricultural land can be constructed here or can be started here, and so much crop yield can take place. But since we need a tank, agriculture here is impossible. So tanks take away a huge cultivable land. That's a disadvantage. Tanks can easily be silted up, which means fine sand and silt can be sedimented at the bottom, which will make it difficult to clean it once in a while. So regular desilting or cleaning of tanks is required, which is a huge and strenuous process. Evaporation of water is rapid due to the large exposure of water in the tanks. See, there's a huge open area in the tank, so more amount of water is always exposed to sunlight, which will cause more evaporation taking place, and that is a huge disadvantage. Tanks do not ensure perennial water supply, which means that if it's too sunny and a lot of evaporation takes place, the tanks will go dry and it cannot support the nearby agricultural fields throughout the year. So tanks cannot assure perennial or throughout the year supply of water. So this is the map of India based on canals, tanks, and wells. You can see canals are mostly found along the river regions, Indus and Ganga plains, the eastern coastal margins where river ends. So those are the orange regions where you find canals. Then you have well irrigation, mostly found the blue patches or the violet regions which are shaded where there's fine soil along Rajasthan or UP or West Bengal. Wherever river flows, there's alluvial soil, and the weathered regions where there's fine soil, it's easy to drill and dig a well. So these kind of regions have a lot of wells, and dotted regions where you can see there's a lot of tube wells all along Uttarakhand and Gujarat. There's so much tube wells which are constructed with the help of motors to dig deeper, because it's most of these regions are near mountainous regions, or some patches are deeper into the middle part of India, but mostly it's along Nepal and China border, consisting mostly in UP and Uttarakhand. The last one being tank irrigation. You can see the pink shaded regions of the southern part of India, mostly in the rocky regions where you cannot depend on rivers, you cannot depend on the fine soil to dig wells. So the hard rocky regions of peninsular India is where you have tank irrigation. Still, these conventional methods have a lot of drawbacks, have a lot of setbacks. The agricultural fields, about 10 to 15% of the land is used for preparing the water channels itself. For example, for preparing the canals or for preparing the tank, for making sure that the well is running properly. All this itself takes about so much of time, energy, space. All the tanks, canals, owing to evaporation of water, the soil may silt, and there's a lot of evaporation of water, which is wastage happening in tanks and canals. The fields in the low-lying areas get excess water, resulting in waterlogging. Subsequently, salt is accumulated and damages the quality of soil because of waterlogging in canals and some areas of tanks. In the conventional system of irrigation, large quantity of water is always wasted, that we see every day from tube wells or from tanks or from canals. There's huge quantity which always gets wasted. So these are the major drawbacks or negatives of conventional methods. So this helps us to push and change ideas to non-conventional or modern techniques in which we can still irrigate plants but save a lot of water. So this is not a technique which we will be learning in our syllabus, but it's a extremely fascinating technique with zero manpower. So human effort is not required in this. Just to lift and put it you need, but the running of this machine does not require human effort. And the surprising thing is it doesn't require fuel, it doesn't require electricity also. So no electricity, no fuel, no manpower, but still you are able to irrigate using this circular pump, which is mainly initiated in the country of Nepal. So that's about the Barsha pump made by the company Aquesta, and it's creating a huge revolution because it does not include any electricity, fuel, or manpower, but at the same time, it can still irrigate crops. These are some other modern irrigation techniques to conserve water, which are very commonly done in our country, and it's much more commonly done in other countries. Drip irrigation, to start off with, are long pipes placed as rows. It's not the picture at the bottom, that's another one. I'm talking about the picture on the top. Long pipes are placed along rows of crops, with each pipe having holes exactly adjacent to the crop base. You can see that there are long pipes all along the rows of crops. The pipe will also go, but exactly near the crop root there will be a small hole. No other place in the pipe there will be holes. Exactly near to the crop and close to the root there will be a hole. There will be only one drop of water which is coming every 5 seconds or 10 seconds, and it will exactly go to the root. So there is no wastage because it's exactly going to the root of the crop. So this allows the drops of water to directly reach the crop and reduce crop root and reduce wastage drastically. The second one is Furrow irrigation, long furrows or narrow, wide, sorry, not wide, narrow, long grooves are constructed or dug out between the rows of crops. So these small gaps, there are small gaps also between between these grooves which connect to each crop, and water is poured in just the grooves, not on the crops. So it will make sure that each crop pulls out water how much ever it requires, and this also reduces wastage, but it increases evaporation compared to drip irrigation. The water is allowed to flow only through these furrows and not through the entire land. Sprinkler irrigation is water sprinkled as drops either from above as an overhead sprinkler as you see in this picture, or from a common center to give a required amount of water from each crop. So in most of the places, sprinkler irrigation and spray irrigation is the same, but when you consider water being sprinkled from the top and water being sprayed from the side, you can divide it into two. If it's in most of the places, water is always sprayed from a common center, so we call it spray irrigation or sprinkler irrigation. But if you want to divide into two, sprinkler irrigation should be the water which is sprinkled from either a common center or from the top, while spray irrigation is through a hose or a powerful jet where water is sprayed from a common center along a margin towards the entire field. So this is the two differences between sprinkler and spray. And sprinkler irrigation uses sprinkles, sprinkled nozzles which just rotate from a common center, and it keeps on rotating and splashes the water. While spray irrigation uses powerful hoses or powerful jets to spray the water throughout the field. So this is the wrap for this chapter. I hope you are able to understand. Thank you.